Yes, thank you. Thank you for picking my presentation. Well, maybe it comes due to the title, the nice pun. I originally submitted it as deep dive into error handling. I thought that's very boring, but I had to wait until the schedule was online, and I immediately emailed, said, "Hey, can you change my title to error handling is boring, but this is the exception." So I hope to make it up with a lot of puns. I was told in the email to be not to be too beginner friendly, to dive really into it. So I have no introduction. Sorry, I can talk about myself a little short. Vito Minheere. I'm from Ede, so I had to drive a little bit to get here. I'm a Python developer. Of course, I work with a lot of Python. I work at Codebees, a small consultancy in Amsterdam. We're with about 8 people, always hiring. If you're interested, you can talk to me outside. And my presentation is about exception handling. I heard about it on the Real Python podcast, which I always listen to when I'm riding to the office. And they talked about new exception handling in Python 3.11. I thought, hey, that's interesting. And I dove deeper into the subject. And what I found, you have to see to learn it. So let's start with, what is an exception? Can we just say, raise exception? No. It will give an exception, so it does raise an exception, but it will say, hey, exceptions must derive from base exception. What is that? Well, it is. Oh my god, this formatting is annoying. This is the right format, and then it should semi-live. Whatever. It's a long list. It's from the documentation of Python, so. It is an object, and an object can have hierarchy. You can have the base exception, well, that is the base, and then you have child exceptions, such as generator exit, keyword interrupt. Those are all Python system-wide ones, but the most interesting one is exception, and Python wants you to use the exception when you create your own exceptions, which we'll dive deeper into later on. But it's very important to keep in mind that there is a hierarchy. So let's raise an exception and see what happens. Oh, we have a zero division error. Most people will know this. If you divide 1 by 0, you will get an error. It's not JavaScript. You won't get infinity. But we can catch the error. Handle is the right word. That's why it says handling exceptions. You raise them and handle them. So we put a try except around it. Say, zero division error, which we saw. So it will say, we have a zero division error raised, and because we did it in the except, it won't raise the exception itself. You can re-raise it. We'll get to that later on. Now we get to the interactive part. My presentation is interactive. This can be interactive. We have multiple exception clauses. So we have arithmetic error and zero division error. Well, you saw in the previous slides, it's a zero division error. So who thinks it will show a zero division error in this part? Raise your hands, please. Ooh, a couple. Well, we're 4 slides in and we're learning already, because this will give a zero division error, but it will print arithmetic error. So this is the class hierarchy, because the arithmetic error is a parent of the zero division error. If you put it first in your exception clauses, it will catch that one, which is very important to know. This is one level down, but you could get quite deep, especially with custom exceptions, and then it will be very hard to figure out. So here we have another one. Well, I won't ask again. You won't be tricked twice, right? This will say exception is raised, because exception then is the parent of the arithmetic error. So you catch the very first one, and if you would say base exception before this one, you would get the base exception. Well, it's not too bad if you mix up arithmetic and zero division. Usually we'll get the same thing. But doing try except exception is pretty bad, because here is some code. Well, I have a spelling mistake and the function does not exist. Well, what would happen now? We have arithmetic error, zero division error. We have some other error handling. Very good one, which just says accept any exception and then pass. So this code just does nothing. It doesn't error. It just say, it's good. Because Python uses the same exception handling for reading and also running your code. So this does throw an exception, but because you accept any exceptions, you also accept that exception, and thus your code will just won't produce any errors. So that's a good one to keep in mind. So you could put anything you want in there except for syntax error, because that's a system-wide thing. You could put any crazy thing there and it will still run. And then the reverse of the order is also very important. So here we raise an exception, which is then the parent class, but we catch or handle a child exception, which, well, it does not work that way. It only works the other way around. So you can only go up the tree, actually. Well, this is not something you do, but maybe if you do a lot of try excepts, you could run into this thing. And here's also a small thing, the Pythonic notation. So as you saw, I did a arithmetic error and a zero division error. You could have multiple errors, but they do the same thing. They both print error raised. Well, that's not very Pythonic because you have too much code. We can put them together in a tuple, and then because they both do the same thing, we could do that and it will go into the same except clause. Well, if you read the extract, there was something about a rocket. What I did was just read some stuff to you. It's pretty boring, so I mixed it up by saying, oh, we have NASA. NASA has a service, and we are going to write a module that will launch a rocket. There was no guarantees. There was only exceptions in this one. So we have a lot of handling to do. Here is some quick code. We have a rocket class. It does some things. It has a fuel tank, which we will get. We will dive deeper into it and see that it is the rocket Artemis 1, which is an actual NASA rocket. I called it Falcon first, but that is SpaceX, and we wouldn't want to mix those up. So here we have a fuel tank. It has a type, a volume, and a max volume. And in this example, we go into the custom exceptions. So we have value error. We saw the zero division error. People know value error, key error. But the best part about it is you can write your own custom ones if you just do it from the exception or from another exception type. So here we have a fuel tank error, and the parent is exception. So we get everything that's in the exception object. And we don't have to put anything in it. We can just say pass. But if we run this and we raise a fuel tank error, we get our own custom error with our own custom exception name, fuel tank error. Well, from this, we can make some child exceptions, such as fuel type error and fuel lever error. And they both extend the fuel tank error, which we'll later on we'll see is very important. And it's good to keep in mind when you make your own modules that other developers will use. So we can add them to our code. We have a refueling function that if you put in the wrong type, for a rocket, it's supposed to be hydrogen. If you put in the wrong type, it will raise that error. And if you put in too much, so let's say you just say, oh, chuck in 1,000 liters, but it takes less, it will say, oh, it's too much, you can only put in this amount. I have to import it from some code that's running in the background because else it will mix up all those things. So we have some imports at the top that will re-import this thing. And we'll try to fuel our rocket with diesel. And as you can see, I put in the fuel level error first, but because we had specific error types, it will go to the fuel type error. So it says, oh, fuel type error, and we can see the stack trace of the error, and it says, oh, you put in the wrong one, you can only put in hydrogen. Now, getting back to the part where I said, hey, if you build a base one, that's very important for your users of your module. So here we have the same refueling issue, which will give the fuel type error, but we only catch the fuel level error or the more base fuel tank error. So this way your users of the module will still be able to handle the error because this is the base error. So it's kind of saying, hey, accept exception, but in a module it's more or less allowed. SQL Alchemy is a good example of it. They have the SQL Alchemy error, which then is the broad error which you can catch in case anything goes wrong. So that's a good one to keep in mind from your documentation. Well, we saw a stack trace of just one exception, but what if we have multiple exceptions? So here we have the same function that refuels our rocket with the same error of putting diesel in it. And here we accept the fuel tank error and then raise another error using the from E. So you keep the traceback of the exception intact while you raise your last error. So if I run it here, we have some other code that will catch it and then also raises from. We can see that it will say, oh, we can't launch the rocket. This is our rocket not ready error. And that is because we have an invalid fuel type error. And you can keep the whole stack if you then catch this error or handle this error and then do from error, and you get a really long stack trace. But it's really nice to see where the actual error comes from. So here we have been handling errors. But what if we don't care about errors? What if we just want to ignore our errors? So here we have our fuel thing again. And let's say, oh, we made mistakes with the fuel. We're going to remove the bad fuel type, but we removed the wrong one. We remove gasoline while we only have diesel and hydrogen. Well, this will give us a value error because it's not in the list. What we could do is the look before you leap. So you check if it's there, then remove it. And if it's not there, you don't remove it. So here we try to remove the same element. It's not there, but it won't give an error. Another thing you could do is try accept the error, but you have here the bad part. You accept an error and then just say pause because we don't care about this issue. It also works. But a nicer thing is to use the context lib, which is suppress, where you can put in any tuple or list of errors, exceptions, and then they will be suppressed, so they won't show up. What this does, it uses a context handler using the with. So it is clearer to the audience reading your code that it shows, hey, these errors won't show up in your code. So it's like this. It's nice if you have multiple things that can go wrong. You can group them together and say, hey, run this part, but don't care about these errors. A good example is the I/O errors of files that are not found. If you want to remove a file, you can just first check if there's a file. If it is there, then remove it. Or you could say suppress the file errors and then remove it. And if it doesn't exist, nothing happens. The bad part about this, you can't have any logging because the error does not even show up. So if you would want to have logging that, hey, you missed this element, it's not in the list, you do need to do the try and accept. So now we put it in a better example using the rocket. I made up the part where we have a transmission coming from a command center and they are sending out messages to different rockets, but we only care about message 1, 2, and 3, the strings in this case. We don't care about the dictionary or the integer. So what we could do is we can do this whole loop and then try, and it also has another nested try because then you will try to get the next transmission, which could raise a stop iteration error. And then in that we will try to strip the transmission, but that could give an attribute error, but we don't care, so continue. It could also give a type error due to the integer, but we don't care about that one. We just want the messages we receive. So it works, but there's a lot of lines. You have 2 try blocks in here. It's a bit of a mess. So if we use the suppress one, we can create a tuple with the attribute error and the type error, and then just say, oh, we suppress these, and we suppress them only while doing the transmission strip. So this works, and it's way neater, and it's clearer for the reader of the code that you don't handle these errors. In the previous example, if you have a pause, someone might think, oh, they forgot to do the error handling, I'll edit for them, and then your code will break. And now the cooler part, which was added in Python 3.11, they added a bunch of stuff for async and also async exception handling. And in my example of the rocket, we can say we will fire up the engines in a asynchronous way, so one by one, to see if the rocket can launch. We have 4 engines in our rocket and we only need 2 to launch, so that is the story behind this. And they added the exception group at the same time as the task groups for async I/O. They're both named group, they're both released at the same time, so they must be related. And here we can see that a exception group also is a subclass of the exception. And here we have some custom exceptions for a ignition error. So we can say, hey, our ignition failed to ignite. Our engine failed to ignite, so we can't launch. That's one error. And we have the more broad engine error, which is any other error in the engine. And then the ignition error extends that one. And here we have some code of random engine failures. So we could have a engine error, something went wrong, or a more specific error, something in the ignition went wrong. And it's random, so it is kind of live, so it could work as well. We don't know. I'll just have to run it multiple times to let it fail correctly. So there's multiple ways in async. We can create a task, then await that task, then get the result, then check if that has an exception, and if it has an exception, we can raise that exception, so then it will go back to it will be caught in the other accepts from the try. So we can run this, and as you see, we got an error. It's not that clear. So it's handling the engine error, but yeah, it's only handling one error at the same time. And you have to go to the next one, and then every task we have to see, oh, does it have an error? Yes, no, can we handle it? Or what if we need to restart 2 engines? Can we bundle them together somehow? Well, maybe if we do async IO gather, we gather all the results and then try to handle them. What the issue is there in this case is it will only handle the last error. So we only get one error, while we could have that multiple engines failed, but we only get one engine in the end where it says, hey, this one has an error. Well, what they added is task groups. So you have a context handler for the async with, and you create a task group and then add your tasks to that. And it has a special syntax, the except star. And the star in Python, it will unpack things for you. So in this case, it will unpack the ignition error from the exception group, and you can handle those. And in this example, we apply the throttle to 4 engines. And if it goes wrong, well, there's only one engine going wrong now with the ignition error, and we get a tuple of the error itself. And if I run it multiple times, now we have issues in 2 engines, and you get a nice tuple with those engine errors. Let's see if I can also get also an ignition error. So then now we can handle both of them after all our tasks are finished in the different tuples. So we have the same kind of syntax, but we can handle a group of similar issues in that part. And now I'll run into something which Jupyter Notebook could not handle yet because it's quite new in 3.11. And there's a whole new traceback. So if we go here, and if I get this, yes. So we get the exception group traceback, and it has 2 sub-exceptions. In this case, we have the engine error and the motor error, and then it will say that it has unhandled errors because we didn't really do anything with them in the task group. And let me go to the next slide, and it's also not formatted. Yes, now it's formatted better. Here you can see that it's one of the exception groups in the errors. So this is the exception group itself for the ignition error in this case. And in the traceback, it will show, hey, you have these errors popping up. So you do have to handle all the errors in the exception group. You can handle them one by one. It is a tuple. Or you can just handle them all at the same time. It's up to you. But if you leave one unhandled, you will get a traceback for that. All right, so can we then finally launch the rocket? We have some part, I explained some part of all the try excepts, and we have the code which I had shown, so we can try to finally launch it. So I set up this part, and something failed in our checkup procedure. But we have good error handling, so we can see, hey, you must use the ignite function to actually ignite the engine. Okay, cool. Let's say rocket engine.ignite. So we will ignite the engine before doing the startup sequence. And now the startup procedure works. So in this case, we are the user of our own module. And because we created our own custom errors, put in some nice error handling messages, we know, hey, we have to do this thing, and it works. So here we get into a little bit more of a nicer syntax. We have a try, except, an else, and a finally. I was hoping to put it more at the beginning of the presentation, but then it wouldn't have a case to use it. So keep in mind you have the story of launching the rocket. And in this case, when we launch a rocket, you will have to clear a launch pad because people can't stand there. And you also have to release it or unclear the launch pad for a next launch. So in this case, we have a try. We try to launch the rocket. There's an exception group. Well, I accept it now just for the presentation. You shouldn't do except exception group. It's the same as except exception. But if we get any ignition error or motor error, we will say, hey, launch is failed. But we still need to clear the launch pad. So that's in the finally clause, which will almost always run. I say almost always. If you find a way to break your program, for example, doing OS exit, in one of the except clauses, it won't get to the finally because your program ended. It will not close it in a gentle way. But what if we don't get an error? So we try to launch the rocket, we accept an exception group, there is none, so we go to the else. Else we can print some information about the rocket, but we still have to release our launch pad, so we put that in the finally clause. So the finally will then, in this case, always run, so the launch pad will always be released for the next launch. And let's see if all of it works. And it does. So we have at least 2 engines fired, so we're launching the rocket anyway. So this is going well with our exception handling. And that is, yes, that is my end of my presentation. I went. We hebben veel tijd over, of niet?
Yeah, there's still some time, like 13 minutes.
Ah, yeah. Well, it is interactive, so if anyone is interested in saying, hey, can you check this out, we can do it. But yeah, there's lots of questions you could ask.
What is the use of the else clause of the try statement?
So the else will...
You repeat the question.
Oh, yes. So the question is, what is the use of the else in this statement? So the else will run... you can see the try except as an if. So if there's an error, we accept it. But if there's not an error, it will go into the else. So then if there's no error, we can print what our rocket is doing. If there was an error, it will go into the except clause. So that's a way of handling. You could also remove the else and then do it one step back. It will also run. But then you would miss the finally if you put it in there. Yes, go ahead.
So you advocated to make custom exception classes for the fuel type and fuel value. Is that a good idea, or should you just use type errors and value errors?
So the question is, you promoted creating your own custom exceptions, but you could also use value errors and type errors, right? In that case, yes, you could, but if you you could override the message, I guess. So you could say, oh, raise a value error with this type. But I think it could be unclear. So if you're a developer, you're using a module and you do have to say, oh, try and accept a value error, then you don't know if it's a Python value error or if it's a value error from that module. So if you create your own module error, you do have to import it though. So that's kind of annoying, but it will make it more clear. It's as you're overwriting your same namespace. So I would say try to use custom errors in that part.
Any more questions? Or maybe one just for, we all maybe know we ask, in Python we say, better to ask for forgiveness than for permission. Is there something you hang on? Maybe not everybody understands, but asking for forgiveness is trying to use the try except, and asking for permission is like in try use if else statements.
We can go back. Yes, so then you meant this part, right? Yes, you look before you leap, so you check if it's there, or else you do the error handling. One thing in favor of using if-else sometimes is in a try except. The try is performance free, so to say, but handling an exception could be quite heavy. So you wouldn't want to do a try except for almost everything you could find in your function, because that would slow down your code. You really want to do only, well, things you wouldn't. It's an exception, so it should be an exception and not something you could handle regularly.
One important thing, though, about those two techniques, which are both discussed in the Python documentation, the easier to ask forgiveness than permission is much more robust against concurrency, which is sometimes very important. Like you can check if a file exists, and then the next line of code removes that file. But if some other process right in between there removes the file, your code will fail. Whereas with this technique, your code will not fail. That's
I do have to
why is it
repeat that,
important?
right?
Yes.
Yes. So yeah, we have a remark from the audience saying that the easier to ask for forgiveness part is better for concurrency. So for example, if you're handling a file and you want to remove that file, but another process already removed it for you, right? Then with catching or handling the exceptions, your program would not fail. Just either throw an exception or handle the exception if you did it correct. While the other part where you look before you leap and then check if the file still exists, then would throw an error you would not expect. So that is one thing to also keep in mind. Thank you.
Oh.
Yes, up above.
What about the performance of Express? Is it as slow as an exception, or is it more like
About the performance, I think if I look deeper into it, it's more synthetic sugar than actual performance. It does the same thing as try except pass, but it looks nicer. It's cleaner. Syntactic sugar.
It's more about documenting intent.
Yeah, you can show your intent better. You can say, hey, we don't care about these errors, instead of writing the try except pass. And as you can see, if you don't combine them together into one tuple, you would have a lot of try except blocks if you were to ignore quite a bit of errors in a specific case. It's maybe not something you would do every day, but it could be nice if you have a list of things where you don't really care about it goes wrong, and you just want to show the intent to the reader that, hey, this isn't something we care about, and you should just ignore it.
No more questions? I can think maybe one, but you say you write libraries and you write exceptions for your libraries. It's always good to have one exception for your whole library. But it's also some practice that you should not make too much exceptions, too much exceptions, like creating too much exceptions. Is there some kind of a guideline of how many or how deep your exceptions should go, like subclass?
That's annoying. Well, there's no actual guideline. I think the best thing you could do is look at the Python documentation. So I showed it in one of the first slides. It goes about 2 or 3 levels deep. I wouldn't go deeper than that. Then it's getting way too specific. You were better off overriding it or creating a exception underneath it instead of add another layer. But using a broader exception, such as the exception itself in Python, is good to handle. To let users handle any edge cases they might miss. You wouldn't want to do all the exceptions you could find in your module and have to handle them every time. You could put a except your special module exception at the end to catch any errors.
Well,
Okay.
Thank you, Vito.